A very good afternoon to everyone present here. My name is Priya Aswani, and today our team backslash has the pleasure of leading you through a presentation and demo of our application SustainMe. 600. To all of us present here today, this might seem a mere number. I promise I felt the same 24 hours ago. And then something magical happened. I read, and that makes me look at this number in an altogether different light. Human beings are consuming resources at a rate much faster than these can be replenished. One day, nothing would remain to sustain life on this planet. But what if I told you that if every one of us today starts consuming only as much we need, nothing more, nothing less, something called living sustainably, we could in fact increase the planet's longevity by that percent, 600. In sustainability lies a solution, but people need to be awakened to living sustainably. And that's where we come in. Ladies and gentlemen, allow me to present to you Sustain Me, a trio of exciting features. So, what do we offer? Number one, augmented reality to allow visitors to go back in time and relive the process of creation of sustainable artifacts at the Expo 2020. Number two, collaborative filtering to curate a personalized list of recommendations for artifact visit. Number three, beacon technology for indoor navigation to help get people to places that matter. While this might have seemed to be an exciting recipe, what are the ingredients of this hack? We've relied on a melange of technologies going from Google AR Core to Android Studio, Maya, Blender, MongoDB, Node.js, and Beacon technology. And now, for the more exciting part of the presentation, let's dive in deep to have a look at how stuff works. This is a system architecture, a very dear client-server model. The client requests services from the server, and the server serves these clients. The backend has been broken into four components, each serving a dedicated function, as I shall explain now. Feature number one, AR animation. When the user scans a QR code for an artifact with a smartphone, the Augmented Images API by Google AR Core detects this QR code. Once this has been done, the API starts tracking the QR code, which simply means that it determines the QR code's pose, orientation, and physical size, so that it knows how and where to place augmented content. Once the API has started tracking the QR code, it retrieves the animated models from the Augmented Images database and starts playing the animation over the QR code. Feature number two, collaborative filtering. Let's suppose Sam visits the Azerbaijan pavilion. He likes it very much and so provides a 5-star rating for it. This rating is then sent over the internet and gets stored in the user preferences cloud database. As soon as the rating has been inserted, the collaborative filter is invoked to generate recommendations for Sam. The recommender system then looks for overlaps in the preferences of Sam with other users at the expo. It uses a set of rules to generate scores for different artifacts and then recommends artifacts in the descending order of scores. Once a list of recommendations has been prepared, the list of recommendations are sent over the internet to Sam, and Sam is notified of the same. More details on the scoring system can be found in the technical poster. Feature number three, indoor positioning and navigation. Beacons are tiny pieces of hardware that keep giving out BLE, Bluetooth Low Energy signals. The Estimote Indoor SDK has a class called Location Manager, which in turn has a method called Start Positioning. This method processes raw beacon signals received from the user's smartphone to provide an estimate of the coordinates of the user. These are used as source coordinates. The indoor location or the house where the navigation is being performed has been divided into tiles and the tiles numbered. Each tile has a coordinate and each tile is adjacent to certain tiles. Some tiles are special tiles. They have artifacts placed on them and these are known as the destination tiles. All of this information is stored on the Indoor Map Cloud database. At runtime, the app interacts with this database to retrieve tile information. Remember the coordinates that we obtained from the start positioning method? These are then mapped onto a tile number. This is then identified as a source tile. When the user chooses an artifact to navigate to, the tile on which the artifact has been kept is identified as the destination tile. Dijkstra's algorithm is then used to relax the edges in the graph of tiles and come up with the least cost to move from any tile to any other tile in the house. There is also a next matrix which stores intermediate tiles in an optimal path between source and destination. This matrix is traversed in a recursive fashion to identify the optimal path between given source and destination. Using this path created by the tiles, navigation instructions are generated, such as move forward, backward, left, right, and so on. With Google AR Course Scene Form Library, these instructions are then displayed as arrows in augmented reality. The user follows along to reach his destination safe and happy.
Hello, my name is Paras and I'll be taking you through the rest of this presentation. Here are some of the major components of our app that we believe can be considered significant contributions to the field of computer science. We managed to develop an indoor navigation feature using quite advanced beacon technology, and we managed to work with Google AR Core, which is also another technology which can be considered relatively new because both of these technologies actually don't have a lot of help available online. So we had to learn how to use them and how to make them work for what we wanted to do. We also managed to implement a collaborative filtering feature which personalizes recommendations for each and every user. And of course, at the end of the day, we managed to combine all of these technologies into a single application, which will be demoed shortly. Moving on to the challenges phase section, one of our biggest challenges was the integration of augmented reality with Android Studio. We managed to do this using Google AR Core and the Sceneform library, but initially when we started, we were actually unable to even load a single model, and animations didn't even seem like they would be happening anytime soon. But we managed to solve this problem through thorough research and working together as a team. 3D modeling and animation was also quite tough because some of the artifacts that we wanted to design had very limited references available, so we managed to work with what was given to us. And of course, designing and coding the indoor navigation feature was another huge challenge because none of us really had any prior experience in this field, so we had to learn how this technology works and how we can manipulate it to do what we wanted to do. App debugging in Android Studio was one of the, if not the biggest challenges that we had because there were times when we felt that we were spending more time debugging the code than actually writing it. Now comes the group learning section. As you can see here, there are actually quite a lot of technologies that we had to learn for developing this product. For example, we used Android Studio for the development of the application, Google AR Core for the augmented reality feature, Autodesk Maya for 3D modeling, Node.js for the collaborative filtering feature, Blender again for 3D modeling, NoSQL and MongoDB for the database design and management, beacon technology and associated features such as Estimate Indoor SDK and Xcode, which helped us set up the environment for the beacon technology and the indoor navigation feature. And of course, we managed to advance our programming and problem solving skills throughout the entire process of application design, development, and debugging. Now we will demo the app.
Hello everyone, I'm Taha and I'll be guiding you with the SustainMe app demo. So I'm launching the screen right now from my Android phone and it takes you, I'm going to the tutorial screen and it goes through all the buttons on the navigation bar. I'm just pressing the next button so it goes to the next slide, but the user can skip any time in between using the skip button. So right now I'm on the camera screen and I'm trying to scan a QR code. So whenever there's a successful scan, it vibrates the phone and it shows a message what you have scanned. So I've scanned the shading tree and now I'm looking for a plane to be recognized for the AR model to be placed on the floor. So I clicked on the floor and the AR model is now on my screen. I can see it on my, from my phone and I press the animate button so I can start the animation of the model. This 3D model will kind of break down and explain how it's been made, what materials it's been using. Okay, so as you can see, like some parts is just falling down and some messages are showing. You can read this, the user can go around it and read it from behind as well, which I'll show in the future parts. So I'll just fast forward this part so we save time. Okay, now that the animation is over, user can press the quick tips button, which will show the materials and tips, and once they're satisfied, they can rate the artifact. So here I'm rating the artifact 5 out of 5, and just pausing the video right now just to show you the screen. So the user is asked to confirm the rating, and then they will get this screen saying thank you for your feedback, and then the user could either check out the recommendations, or they can press on maybe later and go back to the camera screen. So I'm going to press on maybe later. So here I'm back to the camera screen, and I'm just gonna try and scan a faulty QR code to see if it shows me an error message. So here this is the wrong QR code, and it says QR code not recognized. Here I'm gonna scan a right one, and it's gonna show the right artifact name, which is the Australian Pavilion. Now again I'm gonna do the same process again, find the floor and place the model on the floor, start the animation using the animate button. So as you can see, the animation is playing. The artifact is broken down into small pieces, and it's rebuilding, and it's showing how the process is going on. So I'm going to speed up the video a little bit. Okay, so now once the animation is finished, the user can click on the quick tips button, and they're shown the materials and tips. The user can select the rating and confirm it, and now the user's again clicking on maybe later to go back to the camera screen. So now the user is going to scan another artifact QR code. My phone will vibrate as soon as the QR code is recognized, and this time the solar tree has been recognized. And again I'm going to place it on the floor and press the animate button to play the animation. So I'm going to speed up the process a little bit so we save time. So the user pressed the quick tips button, and the materials and tips were loaded for the solar tree. The user will now rate the artifact 5 out of 5 and choose to submit the rating. So here I clicked on checking out the recommendations. I click on let's check out button, and it sends me to the recommendation screen, which in this case Azerbaijan is recommended to me. Okay, I'm gonna pause the video now to just give a brief explanation about how the recommendations are generated for the target user. So we are using collaborative filtering to generate recommendations for the target user. So how this basically works is that it's going to look for other users who have the same rating. So for instance, if there is another user who also rated the artifact 5-star, they're going to be matched with likes, and whatever the other user had liked as well, that one will be recommended to the target user. The same thing will be working for dislikes, but it will be less likely to be recommended to the user. We use a scoring system to order the recommendation, so the most likely are on top and the least likely are on the bottom.
A more detailed explanation about how this collaborative filtering feature works can be found on our technical poster, which can be used to gain a better understanding.
Okay, now so I'm going to be demonstrating the perspective from a different user. So I've loaded the app, and I'm on my camera screen, and I just go to the gallery tab, and I can see different artifacts. I'm just going to quickly sort them by name and click on one of the artifacts, and this screen will open, and I can view brief information about the artifact. I'm going to quickly go back and select another artifact and see the information. Okay, I'm going back to the camera screen now. Scan an artifact. It shows me a message that I've scanned the shading tree. Now I'm looking for a place where I can put the model, and here the model appears. I'm going to start the animation. I'm just going to demonstrate by going around the model that it is possible. You can go all around it, you can like go closer to it, you can go a bit back to see a better view. So I'm just gonna forward this. Okay, so the video is a little bit sped up, so we can squeeze more content in less time. So I'm looking at the quick tip screen and rating the model, and I scanned another QR code, and now I've loaded the Finland pavilion. I know it's a bit big, so I'm just going around it, and I'm looking under it if I can see. So just to show that I can like move closer and go a bit back and go all the way around it. Okay, and now I'm at the quick tip screen, and I'm gonna try and rate the artifact. First, I'm gonna rate it 5-star, and then I'm gonna change my mind and go back and rate it again 2 stars, just to show that we can change the ratings before we confirm it. Okay, so now I'll be passing it on to Youstina, who will be demonstrating the navigation feature of our application.
Hi everyone, I'm Youstina, and now I'm going to guide you through the navigation feature of SustainMe application. I'm launching the app from my Android phone, and the first thing that shows on the screen is the camera, which I'm going to use to scan a QR code. So my phone vibrates and shows that I scanned the QR code for shading tree. Since the animation for it was shown before, I'll go directly to the quick tips and rate it. So the reason we showed the shading tree getting rated multiple times is because now when the user displays his recommendations, he will get recommendations based on his rating and the ratings of the other users who rated the shading tree. As my rating got submitted, I go and check the recommendations that got generated for me. Here the user can view the recommendations and select one of them to view its details. The user can navigate to the Azerbaijan Pavilion artifact by scrolling down to the navigation button and clicking it. In the navigation screen, the arrows show the user which direction to go in. At the same time, you can see a recording of me in real time testing the navigation to go from my current location to the destination, which is in another room. Once the user reaches, he can click on the X button and confirm quitting the navigation. Now the user can scan the QR code for Azerbaijan Pavilion, and once his phone vibrates, he can now move his camera around to look for a plane and tap on the screen to view the 3D model on that plane. Once the 3D model shows, the user can view the animation for it. But for the purpose of this demo, we will speed up the animation. Once the animation is over, the user can click on the quick tips and rate the artifact. Now the new set of recommendations will be generated based on the user's rating of the Azerbaijan Pavilion artifact. Since we tested navigating to an artifact from the recommendation screen, we will now test navigation to an artifact from the gallery. Say we want to navigate to the Sustainability Pavilion artifact. We can scroll down and click the Navigate button, and this will take us to the navigation screen, where the arrows are generated in real time using the output from the beacons and the wayfinding algorithm created by us to generate the next direction the user should go in. Once the user reaches, he can click on the X button and confirm quitting the navigation. Now the user can scan the QR code for Sustainability Pavilion artifact, and once his phone vibrates, he can now move his camera around to look for a plane and tap on the screen to view the 3D model on that plane. Once the 3D model shows, the user can view the animations for it, but for the purpose of this demo, again we will speed up the animation. Once the animation is over, the user can click on the quick tips and view the materials and tips of the Sustainability Pavilion and also rate it. Thank you.